I'm John Lawrence. I serve as the Associate Dean and Director for Ag and Natural Resources Extension and Outreach at Iowa State University. I've also had the opportunity to serve as the Interim Director of the Iowa Nutrient Research Center, worked with a group of scientists here at Iowa State and USDA to develop the non-point source part of the nutrient reduction strategy. So water quality is not a new topic in Iowa, but it's certainly a hot topic today. Protecting Iowa's waters for a variety of purposes, including drinking water, recreational use, and wildlife habitat, is an important topic. There's different uses for our water and therefore different measurements or targets that we shoot towards. We talk about the safe drinking water standard, which is 10 parts per million. We talk about wildlife habitat in the streams for biological purposes. That may be yet a different measure. Another measure we often hear about is the number of water bodies on the impaired water list in Iowa. There's a variety of reasons for those impairments. And yet, as we talk about downstream purposes like the Gulf of Mexico, we talk about our total load or pounds of nutrients, nitrogen and phosphorus in particular. And that's what we're going to talk about today, is Iowa's nutrient reduction strategy and how we measure progress on our strategy goals. Now, the nutrient reduction strategy includes all of Iowa, which includes the cities and factories, the point sources, as well as the non-point source, which is primarily agriculture, but also includes our urban settings with lawns, golf courses, and parks. The Hypoxia Action Plan calls for each state to develop a strategy to reduce the loss of nitrogen and phosphorus by 45%. Iowa's strategy for the non-point source, or agriculture, really looks at three different management approaches. In-field practices such as fertilization rate, nutrient management, the timing and placement of the nutrients, tillage, cover crops, edge-of-field practices such as riparian buffers, saturated buffers, bioreactors, waterways, and so on, and then land use changes. This would be perennials such as pastures, conservation reserve program lands, biomass crops for energy production. The strategy calls for a 45% reduction in the load of the nutrients, but how are we going to measure that? Some suggest we just simply monitor the nutrient levels in streams and rivers. The challenge there is that the concentration and load are highly dependent on weather, particularly rainfall, causing the numbers to change dramatically from year to year and season to season. But we're going to take a broader look at that, and we've developed what is called a logic model. A logic model is used oftentimes in research on challenges that are long-term in nature, like fighting obesity or reducing cancer. We know what the long-term goal is, but it's going to take a time to get there. So if we look at our logic model, and we start at the far right with the end in mind that we want to improve water quality. But before we would see a change in the water, we have to see a change in the land or the treatment facilities in the city. However, it's humans that make the decision about those changes. So can we measure a change in humans' knowledge or attitude or behavior? And ultimately, if you want to influence humans, you need inputs. You need resources for advertising, education, and promotion to bring about change in their behavior. So now if we think of our logic model as a dashboard, and let's look at our four indicators as the gauges on that dashboard. If we can't begin to see the needles change on inputs and the human factor and land use changes, why would we ever expect to see changes in the water? Likewise, if we do begin to see movement in the right direction across investment, across the people side of things, we can feel confident we'll eventually see the changes in the land and the water quality goals that we're trying to achieve. So I'm pleased to say that in Iowa we're making progress on that. We have an annual report to the governor each year, and the 2016 report showed that we are making progress across all four of those measurements. So here are some of the highlights from that report. Public funding is up $10.6 million from 2015. Surveys have showed the percent of farmers at least somewhat knowledgeable of the nutrient strategies increased from 53 to 70% in a year. The amount of land and small grains, CRP, pasture, and hay increased 1.1 million acres since 2011, and then acres of cover crops, and just those receiving cost share, has increased from 36,000 to 317,000 over a 4-year period. Point sources are also making progress. The goal of the Department of Natural Resources was to do feasibility studies on 20 facilities a year. Water monitoring continues to intensify. So more recently, the University of Iowa, in conjunction with the U.S. Geological Service, has established a network of real-time nitrogen sensors. There's 55 of these in the state of Iowa. A third of all of these real-time sensors in the entire U.S. are located in Iowa, and they can collect water samples every 15 minutes. The practice-based calculated nutrient load reduction over the previous year from non-point sources alone amounted to 1,915 tons of nitrate being reduced and 109 tons less phosphorus. So we are making progress towards our goal, but there's still work to do. It's going to take a number of years and a high adoption rate of a full suite of these practices to reach the goal set by the Gulf Hypoxia Task Force. Mother Nature, market forces, state and federal policies all are part of this decision-making process that farmers deal with on a regular basis. But if we stay focused on our 4 elements of that logic model, the inputs, the human factor, land use changes, ultimately we will see a change in the water.